Hey there, this is your stats practice exam for chapter 8. And I'm going to assume that you have the PDF all set up and ready to go for this review. And let's get started. So problem number 1, we have the Carter Motor Company claims that its new sedan, the Libra, will average better than 23 miles per gallon in the city. So we want to come up with our null hypothesis and our alternative hypothesis. This one's about the mean. And remember, the null hypothesis is always equals to. And it says we'll average better than 23 miles. So the alternative hypothesis is that it's going to be bigger than 23 miles per gallon. Number 2. A skeptical paranormal researcher claims that the proportion of Americans that have seen a UFO, P, is less than 2 in every 1,000. So our null hypothesis and our alternative hypothesis, this one is using a proportion, and 2 in every 1,000 is going to be 0.002. And it says specifically less than 0.002. I want to show you where I'm getting that number from. If I do 2 divided by 1,000, 0.002. Number 3. A psychologist claims that more than 5.8% of the population suffers from professional problems due to extreme shyness. All right, so the null hypothesis is the 0.058. That's our 5.8% converted to a decimal. And it says a psychologist claims that more than that. So the claim is that more than 0.058, pardon me, suffer from shyness. All right, number 4. A researcher claims that 62% of voters favor gun control. So our null hypothesis is this is going to be a proportion . An alternative hypothesis, it doesn't say anything, so this just means we're going to assume that it's not equal to. The manufacturer of a refrigerator system for beer kegs produces refrigerators that are supposed to maintain a true mean temperature of 48 degrees Fahrenheit, ideal for certain types of German Pilsner. The owner of the brewery does not agree with the refrigerator manufacturer, and he claims he can prove that the true mean temperature is incorrect. All right, so our null hypothesis is that the mean is 48 degrees Fahrenheit. And the alternative, they are saying that it is not 48 degrees Fahrenheit. So I can squeeze 2 more here. 6, since these are all very closely related. Number 6, a cereal company claims that the mean weight of the cereal in its packets is less than 14 ounces. So this is about the mean again. And this one specifically says less than 14 ounces. Number 7, the principal of a middle school claims that test scores of 7th graders in her school vary less than the test scores of 7th graders in a neighboring school, which have the variation described by sigma equals 14.7. So in this case, our null hypothesis is sigma is equal to 14.7. And the alternative is that they vary less than 14.7. And that's problems 1 through 7. That's just coming up with the null and alternative hypotheses. There. All right, number 8. So they want us to find the critical value z used to test the null hypothesis. So let's come up with number 8. 8 gives us that alpha is 0.08. And they give that the alternative hypothesis is that mu is not equal to 3.24, which implies that the original hypothesis, the null hypothesis, is mu equals 3.24. Now this tells us specifically that this is going to be a two-tailed test because we have a not equal to as a part of this. So I'm going to draw a picture to get us a better idea of what it is that we're doing. Lots of pictures with this chapter. Now this is going to be a two-tail, and we're going to end up with 2 z critical values in this case. Half of it goes here. 0.04 is half of the 0.08. And for this, they say critical value z. I was just making sure that we didn't have information that would make it a t distribution. So I'm going to go second distribution. And this is inverse norm. They specifically in this problem say they want the critical z value. And the area to the left here is going to be 0.04. Negative 1.75, it looks like. And this is going to be positive 1.75. We know this. We're not concerned, but I want to show you how we would get that. In the middle here is the 92, or the remaining 92%, so 0.92. But what I can do instead is I can just do inverse norm again and do 1 minus 0.04. And that'll get me to here. And you can see our 1.75. And so those are our answers here. The critical values are plus or minus 1.75. So that there's 2 of them in this case. All right. We are again going to try to find the critical values with the information that they've given us. They give us that alpha is 0.05. And it's a two-tailed test. They don't even bother with the null hypothesis or anything like that. So let's draw that real quick. So half of 0.05, 0.025. The other half is there. 0.025. And we can go here. This is inverse norm again. And again, we have 2 because it's a two-tailed test. So we have 0.025. That'll give me the left one. Negative 1.96. And that's going to be positive 1.96, but I will show you how to find that anyway. 1 minus 0.025. 1.96. So the critical values plus or minus 1.96. I'm going to go ahead and squeeze number 10 here since it's related. Here they give us that our alpha is 0.09, and it's a right tail test. That means all of it is in the right tail. Now remember, inverse norm only knows area to the left. So because this is a right tail test, I'm gonna have to do my 1 minus trick. Giving us 1.34, it's the critical value. There's only one in this case, is 1.34. All right, moving on to number 11. Let's get a new sheet of paper here. Actually, the back of this one will work. All right. Number 11. So we are going to find the p-value. And we're going to state a conclusion as well. So number 11. Two-tailed and z is 1.95. So we're looking for the p-value. And I want to deal with, they give us at the top, that alpha is 0.05. So I want to set up the critical region first. So because it's two-tailed, we're going to split it. They specifically say that it's z. And if you look, we did this for our previous one, so that's the negative 1.96, positive 1.96. I'll go ahead and show you again real quick how to find that left one. The right one, I'm not going to do. Again, you go to inverse norm, negative 1.96. That's not right. Pardon me. I want, again, 0.025. And there's our negative 1.96. All right, now, our test statistic, 1.95, is barely on the good side. 1.95. The test statistic is not in the critical region. But they want the p-value. Now remember, when I do this to get the p-value here, that's only going to be half the p-value. I'm going to have to double it for the other half over there. So I'm going to go distribution. This is normal CDF, 1.95. The upper is a large number. I say just put a bunch of 9s. And you can see that is barely, barely, barely. So the area here, the blue, is 0.0256. And remember, so the p-value is going to be double that number there. So I'm going to go times 2, times 2. You can see that is barely, barely, barely. So we are going to fail to reject. The null hypothesis. Yeah, I know. Number 12. So they tell us that P is not equal to 0.377, which implies that the null hypothesis is equal to 0.377. They say that the test statistic, this is the test statistic, this was the test statistic, is equal to 3.06. And once again, you know what I didn't state explicitly is that the p-value, which we found, is larger than alpha, which was the 0.05. And that's the reason that we reject the null hypothesis, is when the p-value is bigger than the alpha, we fail to reject the null hypothesis. All right, very nicely, our alpha, our critical region is going to be the same every time. Now I can see right away that our test statistic is definitely in here. So let's find the p-value. Remember, this is going to be .06 and up. And don't forget, I'm going to have to double this number times 2. It's a two-tailed test. So the p-value of 0.0022, which is definitely way less than alpha. So we're going to reject the null hypothesis. That was 12. Number 13. So again, they imply, because P is bigger than 0.554, there, they give a test statistic of Z equals 1.34. Once again, our critical region is the same. Oh, this is a one tail. So it's not the same. So let me redraw that. Been doing too many two tails. Make sure I'm in frame. We're good. All right, so now because this is larger than, this is a one tail, which will change the critical region significantly. And all of the alpha is there, 0.05. So to find the critical value, I'm going to go to inverse norm. Remember, it's got to be area to the left, so it's got to be 1 minus the 0.05. 1.64, we'll say. Now our test statistic is over here. And I'm going to over-exaggerate this a bit. So right there is 1.34. And so this is our p-value here, all that area. And we don't double it this time because it's a one-tail. So here we start at 1.34. The upper is going to be a big number. And here is our p-value. So the p-value is 0.09, which is way bigger than our alpha, which is 0.05. And so we are going to fail to reject the null hypothesis. And we're getting a little on space. I'll push that up. Number 14. They say P is less than 2/3, which implies that the null hypothesis is P is equal to 2/3, which is about 0.67. Now our test statistic, Z is a negative 1.89. This is going to be a one tail again because we have a less than. And instead of it going that way, it's going to be going the other way. So our critical region is here. And to get the critical value, I'm going to go inverse norm. And again, this is area to the left, so it's just a 0.05. Gives us the negative 1.64, which you can see it's the same, right? Our test statistic, is over here. And I'm going to over-exaggerate this also. That is negative 1.89. So our p-value is here. So in this case, norm CDF. The lower is negative 99999. The upper is negative 1.89. Which is definitely less than our alpha. So we are going to reject the null hypothesis. Yeah. All right. We're just going to go through problems 1 through 17 for this video. The rest of them, problems 18 through 28, will be done in a separate video. I was afraid the video would go too long. All right, number 15. Let me scooch this up. All right. Number 15. Carter Motor Company claims that its new sedan, the Libra, will average better than 32 miles per gallon in the city. Assuming that a hypothesis test of the claim has been conducted and that the conclusion is to reject the null hypothesis, state the conclusion in non-technical terms. All right, so this is going to be, since we're rejecting the null hypothesis, there is sufficient evidence to support the claim. What was the claim? That 32, that larger than, more than miles per gallon. Oh, I didn't put the verb or the noun in there. That the car gets more than 32 miles per gallon. That's not worded all that well. The important part is there is sufficient evidence to support the claim. That's the big one. And you can state the hypothesis however you want to state it. 16, the owner of a football team claims that the average attendance at games is 523, and he is therefore justified in moving the team to a city with a larger stadium. Assuming that the hypothesis test of the claim has been conducted and the conclusion is failure to reject the null hypothesis, state the conclusion in non-technical terms. So in this case, there is not sufficient evidence to support the claim that the attendance it's an A there, is more than 523. And number 17, the principal of middle school claims that test scores on 7th graders at his school vary less than test scores of the 7th graders in a neighboring school, which have a variation described by sigma equals 14.7. Assuming that a hypothesis test of the claim has been conducted and that the conclusion is to reject the null hypothesis, state the conclusion. So if we reject the null hypothesis, there is sufficient evidence to support the claim. That the variation is less than 14.7. That's 1 through 17. 18 through 20. 8 will be available for you as well. Thank you.